Question 20. The position of in the predicted table is then we need to know the electron configuration of this element. The electron configuration. So sulfur is number 6. Its extranuclear electron configuration is 286. After plotting the electron configuration, we can arrange the number of electrons in each layer of it. That's the number of electrons and the outer shell electron, the number of outermost electrons to determine that it is located at a certain position on the periodic table of elements. How to judge? First of all, the number of electronic layers of its electrical arrangement. The number of its layers is the period it is located in. That is to predict. Then we can see that it is 3 layers. Then it is located in the 3rd period. Secondly, its outer shell. That's the number of outermost electrons. It represents which main family it is located in. Then the number of electrons left in the outermost layer is 6. That means it is located in group 6. A. To judge this question, we choose B. Question 21. A cup of concentrated sulfuric acid is left in the air after a period of time. The change that occurs is then the topic says that in a cup of concentrated sulfuric acid exposed to air, then it has one of the most obvious characteristics of corrosive water absorption. Then it can mean that the word means that it absorbs water vapor from the air. So instead of using technical terms in our chemistry, we can think of it as a diluted process. Then diluted into change and no change. Diluted, changing concentration volume. Solvent, no change, solute mass, and solute, so we can make a very clear statement about the following options. The options below are divided into 3 categories in total. The quality of the first solvent, the quality of the solution, the quality of the solute. We say that the solute, its mass and molar, do not change during the dilution process. So the solvent, because you draw moisture from the air, so its solvent mass goes up. The total mass of the solution is due to water absorption. So it goes up, solute unchanged, nor does the mass of solution decrease. So in solving this problem, we need to go through the analysis of the topic. We can get from this problem that our concentrated sulfuric acid is exposed to air to absorb water vapor from the air. Absorbs water vapor from the air, converted into our proper noun dilute, and its mass, molar concentration for even volume for an analysis. Use this to make a selection of the options below. Question 22. Which of the following groups of compounds are homologous? What are their characteristics? So first, they need to have the same functional group. At the same time, they differ by several CH2. CH2 meets these 2 conditions. We call them homologs. Okay, here are 4 options. First, we have the same functional group, triple bond. No triple bonds. Triple double bonds. No double bonds. Single bond, double bond, triple bond, so that we have the same functional group that we can judge. The choice of this question is D. And then we repeat. Are they several N dicarbonates apart? The 2 organics of option D are exactly 1 carbonate apart. Meet the requirements. Therefore, we chose D for this topic.
Question 28. Which of the following glass instrument is called a barca? You can see the four instrument chosen. We name it volumetric flask. Final C is the true blocker. And you can see A and D have the flask. By the way, also no need to know what's flask is about. Have a base, shape, and narrow neck. In one word, just bigger. In the below, but smaller in the up. Now, this question we should see question 29. The solution is added to a certain solution producing a white precipitate. The precipitate does not dissolve after adding nitric acid. Which of the following statements is correct? Then what the whole question of this sentence tells us is to add barium chloride to a solution. It produces a white precipitate, and this precipitate is insoluble in nitric acid. Then the following guess is correct for this solution. So about the addition of barium chloride to a certain substance to produce a white precipitate, we need to analyze its sedimentation table. Now we have to do two things here. One is precipitation caused by, and one is the precipitation caused by. So first of all, barium ions. First, a white precipitate containing barium ions. We need to know about barium sulfate, barium carbonate, barium sulfite, barium phosphate. There are 5 kinds of barium oxalate. Meanwhile, the second possibility is the formation of precipitation by chloride ions. Then the precipitation formed by chloride ions is very simple. In most cases, we only consider the case of silver chloride. Then among the 6 possible precipitates of barium chloride, encounter nitric acid but do not dissolve. That is, there are only 2 types of precipitation that are still maintained: silver chloride and barium sulfate. The 2 precipitates no longer dissolve when they encounter nitric acid. Then, according to the information provided by the question stem, these 2 sediments are not distinguished in any way. So, in the final solution, is it the sulfate in barium sulfate that's in the solution, or silver ions in silver chloride are present in this solution? We have no way to confirm because we are not given this operation in the question stem. So we can only say that this certain solution may contain both sulfate and silver ions. So we chose D. Question 13, the reactions between hydrochloric acid and sodium hydroxide. Sodium chloride and water are formed. So here are 4 types of reactions. So here we first analyze the names of the 4 reaction types. At the same time, we write some of its characteristic ways. The first one is called a decomposition reaction. It is usually made from one substance to form several substances or several elements. So in this case, we call this a decomposition reaction. Decomposition reaction, then its reverse word, composition reaction, is a compound reaction. This can be compared with each other. B option, neutralization reaction, is a neutralization reaction. Its formula is usually an acid plus an alkali or base. Generate a salt and water. A chemical reaction equation that conforms to this general formula. We call this the neutralization reaction. C option, permutation. C option is a metathesis reaction. Usually conforms to AB plus CD. The process of generating AD plus CD. We can give an example. For example, hydrochloric acid and sodium hydroxide in this place. Then it is also a kind of metathesis reaction. Sodium chloride and water are formed. Let's take another example. Hydrochloric acid and potassium hydroxide can also form water and potassium chloride. change to sodium carbonate and hydrochloric acid. It can produce sodium chloride. Water and carbon dioxide. Water and carbon dioxide are formed by the decomposition of carbonic acid. So this is called a metathesis reaction and the deoption displacement reaction. Its general formula A plus B, C is equal to B plus AC. For example, iron reacts with copper chloride. Ferrous chloride and copper are produced. Consistent with this general formula is called permutation inverse, should be the displacement reaction. Question 31. Which group of the elements belong to the same main group in the periodic table of elements? Group means columns of it are upper and lower, called a group. Then the relationship between left and right is what we call real time. Then we can look at the relationship in the corresponding periodic table of elements. Then in the periodic table of elements, we can see the relatively complete periodic table of elements. In each sequence, we call a group. We call it a group. We can see that the number displayed on the header and the corresponding Roman letter are the names of the groups respectively. Each rampage we call a foot. We call them cycles. That is to predict. Then corresponding to a B, C, D, among the four options, allicin, lithium, and sodium are in the first vertical row of the periodic table respectively. Then indeed they belong to the same main group. So B, carbon and oxygen belong to the same row. They belong to a group but not groups. C, hydrogen, carbon, and nitrogen do not belong to the same row. Do not belong to the same vertical line. They do not have relationship options that belong to the same column or row. D, sodium, magnesium, and aluminum belong to the same horizontal line, the same predicted. Then among other problems that may encounter this type, we need to hold the 2 points. The same horizontal line is called the same predict. The same vertical line is called the same group. Also for the main group, what we need to emphasize is that in the sequence 1, 2, 3, 4, 5, 6, 7, we call these the main groups. You can see that it is marked with after the number. We call it the main group. When the numerical process wins the bidding for B, we call them other groups. The remaining groups are used to distinguish them. Question 32. Which patterns of atomic radius variations is correct about the following atomic radius ordering? Correct is... So first of all, we need to know that the change of atomic radius is regular in the periodic table of elements. So there are 2 rules about its uses. The first one increases down and the radius increases. Decrease left to right from left to right, the atomic radius is getting smaller and smaller. Then we can look at the periodic table of elements. We can compare their respective positions of the 4 elements given. Sodium, magnesium, aluminum in the 3rd cycle, respectively. Radius from left to right, sodium is greater than magnesium than aluminum. The 2nd cycle boron is above the aluminum, therefore its radius is smaller than that of aluminum. Let's go back to the topic. Let's draw its approximate location according to the rules we just described. P is less than L. The radius is getting smaller and smaller from left to right. So L is less than M and less than N. We have chosen A. Question 33. The electron configuration diagram for Na is: first, we need to know the electron configuration of sodium. Sodium is 11 because its atomic number is equal to the number of electrons outside the nucleus. That atomic number is 11. So how is it arranged? We need to understand the electron configuration outside the nucleus. The extranuclear electrons are arranged like onions, layer by layer. At present, the periodic table of elements in the periodic table can have up to 7 layers. So the minimum requirement for our CSK students is to know how the first 3 electron layers need to be arranged. Each electron shell is called a shell. So about the first layer of the shell, first shell, the largest number we can hold 2 electrons. The second shell we can hold 8 electrons. The third shell we can hold 8 electrons. We at least need to know first. Second and third shells. So now sodium has 11. So 11 electrons, and we fill them up one by one. On the first level, we release 2. The second layer, we release 8. Then we need to arrange 1 for the third layer. That is the arrangement of 281. So the electron configuration outside the nucleus, because it's a sodium atom. So the number of electrons is equal to the number written in the inner circle. That is the arrangement of 11, 2, 8, and 1. So we chose a choice